Alrighty, so now we're moving on to multiplying fractions by fractions. This is probably one of the easier skills for the kids because all they're doing is multiplying straight across. So I'm going to multiply my two numerators together to get 4, my two denominators together and get 15. Now, the way that they complicate this skill is that it's not good enough to just know how to solve it. They also need to know like what happens when you multiply a fraction by a fraction. Meaning, we know that if we're finding only a third of the 4/5, the answer is going to be less than 4/5. But also, like if I flop this around and said 4/5 times a third, it's also going to have to be less than a third. And so, yes, they need to know how to solve this, but also they need to understand that about multiplying fractions together. If these are both fractions less than one whole, then both of their answers are going to be less than each of these fractions. And 4/15 is less than 4/5, and it's also less than 1/3. Now, to draw this in a model, because I know that they've been harping on the models, we're actually going to use an area model to show this. And so again, I always think of this as finding part of a whole. I'm going to represent my whole first, which is 4/5. So I'm going to partition it into fifths. I'm going to shade in 4 units, so that shows 4/5. And then of the 4/5, I only want to find the value of 1/3. That is where I usually tell them to get a different color so that they can see the differences. We're going to split it into 3 rows, and we're only going to shade in a third of our shaded units. And we're going to shade the opposite direction so that we can see where they're double shaded, because that's our answer. And you can check and you can see that we have 4 units that are double shaded out of, if I counted all of these units, 15. So that's the model that goes with this. And realistically, it honestly doesn't matter how they, like which one they show first. They should get the same answer no matter what, because this is multiplication. So if we did the same thinking here, before I ever solve anything, I know that this answer is going to be less than 3/4 because I'm only finding part of my 3/4. But also, if I flop this and I said 3/4 times 2/5, I'm also looking for less than my 2/5 because I'm only finding 3/4 of it. So we'll say less than 3/4 and 2/5. So if I go and do this multiplication, we get 6/20. And if I wanted to check this thinking in a model, I'm going to show these 3/4 first. So I'm going to partition it into fourths. I'm going to shade in 3 of them. I want to make sure I label my original 3/4. Now, of this 3/4, we want to find 2/5 of it. So I'm going to go and partition this into fifths. And then of these 5 rows that we just made, we want to shade the opposite direction 2 of those 5 rows. So this would be the first row. This would be the second row. And when I do that, I can check my answer of 6/20. I have double shaded 6 units out of how many total? 20. And so the big idea that we want them to understand with multiplying fractions by fractions is not just how you get your answer. That's part of the standard. The other part of the standard is understanding what you know about your answer. So like being able to make a prediction about my answer. Because I'm multiplying both of these fractions less than 1, the final answer needs to be less than both of the parts that gave me this answer. This is a little bit different though once you start having like something like 8/5 times 1/2. This answer would have to be larger than half because 8/5 is greater than 1 whole. So anytime I multiply something larger than 1 by something, it's going to give me something larger than what I started with, which was 1/2. And then if I flop this and I said half times 8/5, I know that my answer actually has to also be less than 8/5 because I'm only finding half of it. It's like the thinking is we want them to understand what happens when you multiply fractions, not just multiplying straight across to get an answer. So like on their extra credit that they were doing, this would have been problems 5 and 6. They would have multiplied straight across to get 12 45ths. Here it would have been 4/21. And then when you flip it to the second page, there were these questions where they had to tell me what they knew about their answers. Like, I wasn't really interested in them answering it to give me their answer. They should know that because they're only finding half of 3, this answer had to be less than 3. The explanation would have been, we're only finding part of 3. Less than 1/2 of 3. Meaning we're finding less than that. If you did the same thinking for number 8, you're looking for 3/4 of 8, it's going to have to be less than 8 with the same logic. I am multiplying it by something less than 1/2. I didn't have to solve these to get my answer or my explanation. I'm using what I know about fractions. I'm using my fraction understanding to explain that. If you look at number 9 was asking, is the product going to be greater than 1/3, less than 1/3, or equal to 1/3? Well, if you're finding half of 1/3, because you can swap the order in multiplication, I know this answer is going to have to be less than 1/3 for the same logic that we did in these two. I'm multiplying it by something less than 1/2. If you look at number 10, though, number 10 is different. You have 5/3 times 1/2. We know 5/3 is greater than 1/2, meaning the product is going to result in something greater than 1/2. The reason 5/3 is greater than 1/2, and when you multiply something greater than 1/2 by a fraction, it's going to result in something larger than 1/2. And that's really the thinking we want them to understand when it comes to multiplying fractions. And this right here is called scaling. There are some anchor charts in their Google Classroom with scaling. But it's more than just like being able to get an answer. They also need to understand why their answer makes sense, which is what makes this a little bit more challenging for them because they don't really understand fractions to begin with.